All right, so Foundations Math 10, cumulative review. I was asked about number 4 here, so I'll do number 4. Anybody wants to listen to this, you can. I probably won't do the whole thing for you to reveal the answer because it's part of your assignment, but I will give you I'll run through most of it here for you, okay, on how maybe you should think about doing this. So it says, an equilateral triangle is inscribed in a circle. So 2 things already. Equilateral triangle, that means that all the sides are equal, and they are denoted such with these little tick marks, right? That means that all those sides are equal, so it's equilateral triangle. The lateral sides are all equal. And inscribed in a circle, please remember that inscribed means that the points of that shape are on the edges of the circle, okay? If you have a circle and you have a triangle in a circle, that is not inscribed, okay? This is inscribed if all of the points somehow touch the edge of the circle. And I probably won't be able to do this way, but do you know what I'm saying? If they all touch the edge of the circle, pretty close right there, then you have it's inscribed. Got it? So this is inscribed, all the edges, the vertices touch the inside of the circle. Okay, the radius of the circle is 21, so it's shown here in the diagram. That's 21 inches, and that of course is the same radius to all parts of the circle, including to the corners of this triangle. Determine the side length of the triangle to the nearest tenth of an inch. Okay, so what I'm going to do here is I'm actually going to just zoom in on this. I'm going to zoom in on this little circle so we can make it bigger. And let's see if we can do this here. So, okay, I'm going to plop that down and just zoom in. Okay, so an enlarged version here, right here. Nice. Okay. Come on, get rid of that little top part. There we go. Okay, so we want to find the length of this side, right? We want to find the length of one of the sides. So two things. I know that, and I drew this before, but I do have another radius over here, right? That is also 21. Okay, that's also 21. Okay, so I have I have that. I have a triangle, and if I redrew that triangle out like this, it might look something like this. Okay, so there's the 2 radius of 21, and here's my side. Now, do I know anything more about this diagram from what's given? I don't see any other numbers given, but what else could I know because of this situation? It's an equilateral triangle. Awesome. So what does that mean about these angles? Because I don't know what the side lengths are, but I know what these angles are. They're going to be 180 divided by 3. They're going to be 180 divided by 3. Perfect. So this is going to be a 60-degree angle right here. That's going to be 60 degrees. Now, does it make sense that this 60 degrees is exactly bisected, which means that it's split exactly in 2? Yeah. Does that make sense that might be that way? Yes, it does actually. So this is 30 degrees on either side here. Okay. So that means I could figure out this angle, but more importantly, what might be easiest for us to use is the fact that if you split this exactly in half, you would have a 90 degree here, right? And so if I know that this is a right triangle and I know that this is 30 degrees, I can solve for a lot of things, can't I? Now, do I know any other lengths though? Oh, I know 21, which is right here, right? Okay, so I'm going to let you do the rest now, because you should see a right triangle in there with a angle and one given side, so you should be able to find any of the other given sides. So what I would do if I were you, I would find this side right here in this right triangle and then multiply that by 2 to give you this long side. Okay, so that's a multi-step problem there on the trickier side, but go ahead and finish that and check your answer with that one. I'll show you the answer in a few minutes once you've had a chance to take a peek at it. Okay, so there should be your answer to number 4. Using your trig there, you should get 18.2 as a length for this little side right here. And then if you double that, you should get the length of that side, 36.4. Okay, any questions about that?